Ooh, that's good coffee. Hey everybody, how are you? Welcome to Coding Studio. I hope you're having a great week. In this week's episode, we're going to cover a creational pattern. We're going to go over a software pattern. It's categorized as a creational pattern. It's called a builder. We're going to go over the builder pattern, how you would create it, when you would use it, kind of the ups and downs of that. If you're not familiar with the builder pattern, if you're not familiar with how to implement it, maybe when to implement it, when to use it versus a constructor, hey, stick around. We're going to jump right in. Alright, hey, so let's go ahead and get started. On my desktop here I have a class called Builder Example. It has a main method. I've already went ahead and prepared code for us so we can go through it quicker. So in this class you can see I am actually creating this person called Shane. So I'm doing a person called Shane. So I've got person Shane equals new person. Now notice I'm doing a dot person builder. So I'm using a builder pattern. Now this builder is a class that's internal to person. If I go over to person here, I'm going to look inside this person here. I've got a static class called person builder. So here's my person class. I've got public class person. I've got these properties, UUID equal an ID. I've got these properties. I've got an ID, which is a type of UUID. I've got my first name, my middle name, my last name. They're all strings. I've got a constructor that's package scope. This constructor could actually probably be private. I'll go ahead and set it to private. Let's see if that breaks anything. So again, I have this person class. I've got this constructor. It's private. It has a constructor that takes in all the values that make up the person. And inside of this person class, I have a static class, a public static class called person builder. Now, you'll notice that person builder also has the same properties. So this is a little bit of overhead to a builder pattern, right? I'm actually duplicating these properties here that will actually go into the person object. So a little bit of overhead there. Now, this person builder class has a constructor also. And the reason the person builder class has a constructor is the same reason you would have a constructor on any object. I basically want to tell the person using this builder, here are the properties that are required to have a complete person. So this is kind of a way of me self-documenting with the builder. Hey, when you build person, these are the three properties you for sure have to set. So that's one way of writing it cleanly. Basically, it's self-documenting. So I have a public static class person builder. It has the same properties as my person class. I have a constructor on that builder that basically specifies the required properties. Now it's very important when you create an object that if you have an object that requires certain parameters to be whole, in other words, a person should have, in my case, I need an ID, like an ID for a database, got to have it. And in this case, I need the person's first name, that's required. Every person is going to have a first name. I need a person's last name. Every person is going to have a last name, that's required. Does every person have a middle name? No, not everybody has a middle name, so I didn't put middle name here, right? It's not necessarily required, right? So in this builder, it's not required. Now, I do have this method here called middle name. It's part of this static class. Now, middle name, it's public, and I return the person builder. So I have a static class builder. It has a constructor, and then I have a method on it that is called middle name, and that returns the person builder, right? Returns this static class back to the calling client, and the person builder takes in this middle name, and this middle name is set using this dot middle name, just like the constructor sets the other properties. And then I return this, so I'm returning the same person builder that they're actually using. It's kind of a way of, I'll show you the API in a minute, of creating an ongoing type. I don't think telescopic is the right word, but ongoing type of API. I forget the right term. Hey, if you know that term, leave me a message below. I forget it. And then I have a build method. So I have a person class. It has a private constructor. Inside of that class is a static person builder. It has the same properties as the person class. This builder is what's going to build a person object. That person builder has a constructor that self-documents what's required as far as properties that are required for that builder. That's what's kind of self-documenting. And then I have other methods. Now, if this person class had other properties other than middle name, say it had social security number or phone number, whatever, I would have another method here, not just for middle name, but I have another one that operates the same as this, but it would be for phone number or for address. Right now, we're just going to stick with middle name. And then I have a build method. Now, notice this build method returns a person. So person builder build returns the actual person. What does it do? What does this build method do? Well, this build method does a couple of things. First, it validates. It validates that what is required, or whatever the rules I want to validate up front, it validates those rules before it returns the person object. In this case, I'm enforcing with validate that the first name was set and that the last name was set and the ID is not null. Why am I validating that? Because that's what makes a person whole. For a person object to be instantiated, it needs those properties. And you want to follow a principle, basically failing fast. You don't want to be able to set null properties on an object when those properties are required, and then later on you're performing an operation on that object and you get an error, like say in a new method in that object, and there's a null pointer. Well, why is it a null pointer? Was it because somebody passed in something that was a null pointer at that particular time in the process? Or was it because when they first created this object several steps back that somebody passed in null? Well, fail fast. That's a principle of for better troubleshooting. Write your code to fail fast so you'll be able to debug easily. All right, so I have a validate method. So my build method, it validates the parameters that are being passed into the builder before I create the person object. And then I go ahead and use those parameters and I create that person object and I return it. So pretty simple here. It's kind of weird if you're not used to seeing a static class, right? I have a class within a class. I have a class person and I have a public static class person builder. Let's see how you use that. Go back to my example. I've got Shane. I've got person Shane, the variable Shane equals new person. Well, if I do dot, you're going to see, well, there's that other class. I want to go new, and I'm going to use that other class to instantiate person.person builder. So you'll see here that I've already done that on this line. So I am basically at that point have created a person builder object. And when I created that object, I passed in the constructor the ID, first name, and last name, those items that are required. Now, when I did this new person builder, I now have, at this point that's highlighted, I now have a person builder object, right? And I'm going to call a method on that person builder. I'm going to call middle name, right? Now, this middle name returns, it sets the middle name, and it returns the person builder again. So I can call other methods on the person builder. If I had other properties like social security number, I could do middle name, set it, dot, social security number, then set it, and then dot, build, right? You can just keep adding more and more properties into this structure. Your required properties would be here, and then the properties you want to add on and on would be here before you call build. Now, keep in mind, you can't put all your properties here that are required. Sometimes you just can't do that. If you can do that, it's cleaner, it's nicer because it's kind of self-documenting. Sometimes you can't do that, no problem. You don't have to have the constructor. You don't have to use that self-documenting. You can actually put the methods here along with middle name, and what will happen is build will check and make sure all those required parameters are there. It already does that anyway, right? So you don't have to do this with a constructor and person builder, but it's very clean if you can to do that because it's kind of self-documenting, right? So let's say you had 6 parameters that were required. Well, don't do that. You don't have to use a constructor. Make the constructor pass in nothing, right? And then just add your 6 parameters as separate methods in this little line by line here, right? You'd have dot middle name, dot first name, dot ID, etc., dot build, right? And your build would then validate the ones that are required, 5 or 6 properties are there. You fail fast. Okay, so all right, so let's go ahead and run this. Alright, from running this, you'll be able to see I did create a person object over here. It basically created my ID, my first name, my middle name is Shane, and my last name Crouch. Right now, if middle name is optional, I don't have to call it. I can do this, and I can run it again, and there we go. It didn't require it, so it said that it's null. No big deal, right? Now, what if I change my first name to null, right? Well, what if my first name I pass in null? What's going to happen? Well, let's run it. There you go. You'll see that my validate method caught it, and I threw a legal argument exception. Required parameters missing. Right? So my build method is making sure that whatever is required to create that object is a whole object. Right? Not an object that has missing data that's required, but a whole object. Your build method does that. Right? So your constructor of your builder can be used to kind of self-document what's required. Sometimes you can't do that because there's too many parameters. At that point, you would just add them one by one, right? Middle name, put in my middle name, right? You just add them one by one, and then your build will tell you when you run it which ones, if any are missing, it will let you know which ones are missing. Now, what if I wanted to have a way to create the person object, or have a builder that supports passing in two different types of IDs? Maybe my system has a REST service, and I usually get the ID for the person as a string, or maybe it comes from the database as a string. It's a unique ID, but it's a string. Now, instead of having code at different places all over the place in my project to convert that string to UUID before I create the person, so instead of doing it on the outside here, right, I could do it on the inside. So how would I do that? Allow the builder to support string, but also to allow the builder to support UUID. How would I go about doing that? I've got some code here. I'm gonna cut and paste, save a little time, right? So I'm gonna add this here. Wrong class. I'm gonna add this. So I'm gonna add this here. Scroll up a little bit. Now I've got this string. It's a unique ID, and I want to be able to pass that string in, right, as a property. I want, instead of having that code that converts it all over the place, I want that to be part of the builder so it can be reused, one central place. Well, let me go ahead and change this builder to support this signature. You'll notice here that I got rid of the ID as part of the constructor. I don't have to have it there self-documenting. In this case, I don't want to, because I want to support a couple of ways of passing it in. I'm going to let my build to be sure to force that, right? So I've got a person object. You create a builder from it. I can pass in first name and last name. I can do .middle name, .id as a string, and I can call build. It's going to do the validation. I also have the same builder. The same builder allow me to, I can create a person builder, pass in the middle name. I can also pass in an ID that is a UUID, not a string, and then call it build, right? It supports both ways of creating the object. It's very flexible, very simple to use, very neat, right? Let's go ahead and add the code for that. So I'm going to cut and paste a little bit, make it a little bit simpler. All right, so you'll see I still have my person builder, and I still have the properties. I have a constructor. Now, instead of having this ID, well, I still have it. I can still have the constructor that has the ID. I can use that if I want. Don't have to, but I can. I also can have the constructor for the person builder that doesn't pass in the ID. So I've got first name, last name. I go ahead and set first name and last name of this object here, right? And then I have the property on the person builder, or the method rather, ID, where I pass in a string ID. Now I'm going to basically check if that string ID is empty, and if it is, I'm going to set it to null. If it's not empty, I'm going to convert it to a UUID, and I'm going to set the ID to that. And then I'm returning this. So that lets me return the person builder, and then I can call the next one, which would be middle name. I'm still setting the middle name like before. And then I call build, and I still validate like before. I still create the person and return it like I did before. So what's the difference here? Well, the difference is I have two new methods on here. One takes an ID as a string, one takes an ID as a UUID. And I added a new constructor on person builder that allows me to not have the ID passed in as part of the constructor, right? Now keep in mind, I could just get rid of both these constructors if I don't want to be somewhat self-documenting there, and just have a method for each one of those properties. I like to have the constructor there as much as possible, especially if I don't need to do something like this. That way it's kind of self-documenting. These are the required items. You can kind of see as you're programming what's required. You don't have to run it and wait for build to tell you something's missing, right? All right, so this is the minor change. Go back to my example. You'll see it now compiles. Here's the first example. I'm doing Shane equals new person dot person builder. So I'm creating the object person builder using the constructor, two properties. Now that I have the person builder, I'm calling dot middle name on it. I'm calling dot ID to set the ID using string, and I'm calling build, and then I'm going to print it out. That's using the string ID to create the object. Next is another example of, again, I'm creating a person builder. Shane equals new person builder dot middle name dot passing in the ID as a unique ID dot build, and build does the validation again. So this one's creating it with a string, this one's creating it with a UID. See how it's kind of encapsulating that logic. It's allowing a more friendlier interface that handles different situations, and it actually encapsulates the logic of checking out whether the ID is empty or not, and creating a UID for you. So you don't have to have that code other places, several places across your app. Okay, so let's go ahead and run it. I've still got this illegal argument here. Where did I leave that at? No, I've got to fix my first name there. Let's go ahead and put that back. Anthony. All right, let's run it again. Okay, now ran it again. You're going to see I have three persons from the first example. Here are the next two examples we just added. You'll see that my person ID is set. Name is Anthony, middle name is Shane, last name is Crouch. You'll see again on the third one, my ID is set. Now the second one was set using a string. The third one was set using a UID, right? So there you have a builder that allows flexibility, right? You can set certain properties using a string or using a UUID. You can use either way. You have a method at the very end. And this is important. Build is not just there to just build it, put those properties and set it. I mean, you could do those things with, you can do that with a constructor and using .set, right? Build is also there not just for setting the properties, but also validating to make sure whatever object you're creating is whole. Now, what are other reasons for using a builder? Why would you use a builder? Why not just use constructor? Well, builder is usually used when, well, using constructor gets too large. You have 4 or 5 plus parameters. You know, keep it simple. Use a constructor when you can. You start passing into a constructor several parameters, then start thinking about other patterns. Building is one such pattern. When else would you use a builder? Well, imagine there was just complex logic here based upon what you passed in, right? Well, it makes sense, that logic that builds person, it makes sense for that logic to be in a different class than person, right? It would be in the person builder class. So this is a separate class of person, right? I know that everything's required for building a person is in that class, right? It's encapsulated there in one place. So hopefully this makes sense to you. Keep it simple. Use a constructor when you can. If it starts getting quite large and you want to pass in multiple parameters and you want to make sure those parameters are there, then use a builder. That way you can actually validate that the properties are set right and your class is whole. Check out this builder. there's a lot of code here to do a builder. Would I use a builder for a class that has 3 properties? No, I wouldn't. It's overkill, right? I don't need this extra pattern to do that. Now, I could use frameworks like Lombok, and basically Lombok will provide you that builder for you. It'll actually let you use an annotation and put a builder there for you as it compiles it. So you wouldn't have to write all this infrastructure. But when you do that, I think we're forgetting one key point. We're forgetting the validation. The whole point of having, or one of the main reasons for having a builder, is so you can make sure what you build is complete, it's valid. Also, by creating the builder yourself, you can take that logic, like converting a string into a UID, checking whether something is null. All those checks, all that validation, put that in your builder. If I just use Lombok to be my builder, then my builder doesn't do much for me, right? I don't have any validation. I don't have any multiple interfaces to use that converts a string to a UID or allows me to use just a UID, right? So to me, in a way, unless there's other ways to use this builder annotation with Lombok, there might be, I haven't investigated, but just using the default, it doesn't provide much value, right? So I would always argue, 2 or 3 properties, use a constructor, keep it simple. Start having more than 2 or 3 properties, then use a builder and create your own builder. There's no need to use Lombok. Or if Lombok provides a way to actually create the build method where you can do validation, where you can do transformations, then yeah, use Lombok. But otherwise, I would just recommend you create your own builder. Don't use Lombok. That's the whole point of having the pattern. A builder pattern is to hide that validation, to hide that building, to hide that construction or conversion, to hide those checks in a central place. That's why you want a builder. All right. So, hey, that's it. Hopefully it makes sense. I know I'm kind of jumping all over the place. Mine's everywhere tonight, but hopefully that makes sense. If any part of this you didn't quite understand, hey, leave me a message below. I will get back to you. My goal is to help others learn how to program. And don't get me wrong, I don't get it all right. Sometimes I get it wrong too. So if you have various opinions on this, feel free to give me your opinion. I'd love to hear your opinion. But hopefully this makes sense. Hopefully you understand how a builder pattern works. If you don't, drop me a message. Let me know. If you like this video, click like. And if you haven't subscribed yet, click subscribe. I really appreciate that. It helps us a lot at the Coding. It helps get the word out. We really appreciate you. Thank you for joining this week. We hope to see you again in the future. Have a great week. Bye.